Hello, today we are going to talk about chemical formulas and how we actually construct chemical formulas. It's very easy indeed. If somebody asks you what is the formula of aluminium oxide, for example, if you have memorized it, it's not good enough. You have to know the approach, the systematic approach as to how you do it. So how do you actually approach it? Aluminium is from group 3, isn't it? So what do metals want to do? They want to lose electrons. So what does aluminium want to do? Lose 3 electrons. And if it loses 3 electrons, it becomes aluminium 3+. Oxygen, on the other hand, is in group 6. So it gains 2 electrons, doesn't it? So it turns into oxide ion. And then you put these ions next to each other, like that. If the charges balance each other, then that is the formula. If they don't balance each other, you cross multiply the numbers. So it becomes Al2O3. And the reason that is on this side it's 6+, and on that side it's 6-. Now they balance. So the formula is that. And it works all the time. If, for example, you have the formula of sodium oxide, sodium group 1 loses 1 electron, Na1+. Again, oxygen, we've already learned what the case of the oxide ion is. Then you put Na1+, O2-, and therefore the formula is exactly Na2O. So you see, in chemistry, we don't take guesses. There are always a systematic approach that we can use in order to formulate. What about salts? What about, for example, if somebody says, what's the formula of sodium sulfate? For that, you need to know the formula of the acids. Let's write some of them down. Like hydrochloric acid, sulfuric acid, nitric acid, carbonic acid, or phosphoric acid, carbonic acid. Now, again, you don't need to memorize anything. If somebody says, what is the charge of sulfate or nitrate or phosphate, you can work it this way as well. Hydrochloric acid has 1 hydrogen ions that it releases. So that side is 1+, chlorine is 1-. And therefore, sulfuric acid 2+ over here, so sulfate ion is 2-. Therefore, nitrate is 1-. Therefore, phosphate is 3-. Therefore, carbonate is 2-. Because they have 2 hydrogens, 3 hydrogen, 1 hydrogen, 2 hydrogen ions, 1 hydrogen ion. So what is this related to formation? Let's say you want to work out the formula of aluminium sulfate. Aluminium, wasn't it 3+? What is sulfate? From the acid, you worked out that it is 2-. Do the charges balance? No. What do we do? Al2SO4 3 times. It's not something you can take a guess in order to formulate, but it has a systematic approach in which you can work it out. Now let's go back to the other example I gave you earlier. So in your head, work out, for example, what is the formula of, I don't know, calcium nitrate. Isn't it CaNO3 twice? You see, that's how it can be simply worked out. Now let me tell you something else in terms of balancing those formula. Now you know that when you react aluminium with oxygen, the formula is Al2O3, isn't it? So you cannot write anything else. Anything else would be wrong. Now, the easiest way to balance equations like this is that if you have a non-metal which occurs with an odd number, which is the case here, you multiply the whole thing by 2. You turn odd numbers into even numbers. And now you have 6 oxygens on the right-hand side, and you have 4 aluminium. It works all the time. Let's say, for example, you react, what did we say, sodium plus oxygen, to produce Na2O, odd number, isn't it? Multiplied by 2. 2 oxygen, 2 oxygen. Leave it, 4 sodium, 4 sodium.